So today is assessment 1 day. We have 3 internal groups, so each one will present individually. Who wants to go first? You go first? Speed it up? All right. Before you start, be sure to say your group number and who's involved.
Yeah.
And to advance this, and everyone's going to have slides over here, and to advance them, you have to hit the next one. So it might be good if the person talking is maybe standing about here. So if you all the, because here's the microphone too.
Okay, gotcha.
So that maybe everyone can go over there to start with. You're all going to present.
Yeah.
I'll control camera work.
Do we start? Okay. Good afternoon. We are Group 2. My name is Tom. This is Ethan, Mishka, Yanni, and Suzanne. Our group looked at speed and accuracy. In our study, we conducted the experiment Speedy Dots, which tested the speed and accuracy of individuals. This required individuals to try place as many dots as they could into boxes within 10 seconds. In this study, we look at determining whether distance and or box size results in a change of speed and accuracy. Also, how these factors alter each other. Wayne Wk4 showed that there is a trade-off between speed and accuracy. Although Wk4 showed that there was no trade-off. Speed and accuracy are directly related. For example, in order to be more accurate, the individual must slow down their speed. We look at determining what improvements to the experiments could be done to make the results more reliable and consistent, including human fault and technology advances. We aim to determine if the size of the squares and the distance between the squares and or the speed had an effect on the person's accuracy. We hypothesize that as the size of the box increases and distance between the boxes decrease, the speed and accuracy will increase.
Okay, so the equipment that we used to conduct this experiment consisted of 8 sheets of paper, each that had 3 pairs of squares. Each paper, the squares had different ratios in centimetres of the square size to the square distance, as you can see up on the board. We also used felt tip pens. Felt tip pens, and we used a stopwatch as well to time. To carry out the experiment, the participant randomly selected one of the pages, and while the instructor used the stopwatch to measure 10 seconds, the participants dotted inside each square of one single pair as quickly and as accurately as possible. To measure the results, the participant could count the dots that were left behind from the pen after the time was up, but as this did become a bit complicated when the dots overlapped, people did start counting as they went along. Do note though, if there were 4 or more misses, that we did redo that trial.
So these are the results for our experiments. A cross tabulation was created displaying the mean, speed and accuracy for each variables. Box size 1 centimetre by 1 centimetre, 2 centimetres by 2, distance less than 6 centimetres and distance greater than 6 centimetres. From this, a bar graph was formed, see figure 1. This shows the relationship between each variables. In this figure, it can be seen that the mean hits are far greater when the box size is 2 centimetres by 2 centimetres and the distance is less than 6 centimetres. Thus, this can be clearly seen that when box size increases and distance between the boxes decrease, the speed and accuracy both improve. In figure 2, a scatter plot plotting the mean misses and mean hits has been developed. The scatter plot is used to find the relationships between the two variables. A regression analysis has been performed on the data to determine the relationship. After the regression analysis, we see that the coefficient of determination, or R squared, is equal to 7e to the negative 5, which is less than 0.1, which means there is no correlation between the two variables. The coefficient of determination is a useful measure of predicting the dependent variable from the independent variable.
So during the speed and accuracy trial, there was a few areas for improvements. One was our human errors. As we recorded all trials by hand, one trial ran 4 seconds longer than required. This caused the results to be unreliable. And as the test papers were done at random and some participants did not record which trial this happened on, the results were also unreliable. As well as counting dots by hand, some were overlapped and some were missed, which caused them to be overlooked. To minimise these recording errors, one person could have been assigned to record all results. Also, the use of technology such as iPads could have been used as timing and accuracy for the amount of dots. Given that the task was a closed and continuous movement, the motor control was quite high. As box size decreased and distance increased, it became slightly more cognitive. Fitz suggests that it's logical to suspect the slower the movement, the more accurate, as there is more time to detect error and make corrections, though the time between taps increases when there are more cognitive corrections to be made. Hence asserting the cognitive involvement as supported by Schmidt and Lee 2014. The hypothesis was supported that when the box size is increased and the distance is decreased, speed and accuracy would also increase. Speed was found not to be directly linked to accuracy, as though it was seen that when the boxes got smaller, accuracy was still quite high. Zycon and Wren 2004 found that there may not be a speed and accuracy trade-off, as their results indicated that there was low correlation between speed and accuracy.
Okay, and to sum all that up, so the hypothesis was supported in that as box size increased and distance between boxes decreased, there was an increase in speed and accuracy. However, our results did determine that there was in fact no correlation between the speed and accuracy of variables, although different parameters used would have given different measures of speed and accuracy. They still determined that there was no speed accuracy trade-off. A limitation to the experiment was the sample size, so it was quite small, and that obviously the technology that we used was not as advanced. So as you can see in the more accredited studies, there was a larger sample and better technology was used, providing more accurate results. That was our assignment, Speedy Dots, and these are our references. And if anybody has any questions, fire away.
So you say your main results, you say that speed and accuracy don't correlate, so there's no trade-off?
So there was no trade-off between speed and accuracy, so our results showed that there was no exact correlation between the actual speed and accuracy.
Can you go to that regression, that figure that you did? Okay, so can you explain this a bit more? Because you said you used the mean of
Yep.
misses and mean of hits, and how many there's more than 8 groups, so I'm a bit,
Alright, so this is the mean of each individual's performance. So this is the mean of how many misses they missed in total and how many hits they got in total
of all the trials,
of all the trials,
of all the distances,
of all the distances.
and you average all that together.
Yes.
Do you think that's a good idea?
From what we found, I did each of them individually as well, and they all showed the same correlation.
What same correlation?
That there was no correlation between
So you did each of the groupings?
each of the groupings between, so each of the different box sizes and distance as an individual one, and then I did them all together as one.
Okay. Did you do like group the like in your other one you group the box sizes
Yep.
and you grouped it? Did you
Yep.
also do that?
Yes, yep, for the regression, and then but I only put this one up because this was the total of all of them.
So if you would just put this up and not explain that you've done all the others,
Yep.
and also mean doesn't tell you which ones you meaned and which parts you did it. Without saying you did all the others individually,
Yep.
it's just not, you don't understand what you're
Yep.
looking at. Okay, so you've done all that. So you want to convey that before,
Yep.
so you make sure that you said, oh, we've done all the analysis. There are no correlations across all. So, okay. And then the speed versus the other graph you did? What's missing here that would help you be able to tell if this is actually a significant difference, or what? Like if you could look at that and say, oh, what's missing?
The p-value, is it?
Yes.
Yeah.
But what's that based off of?
That if that's a significant difference between the changes.
And generally, if you're trying to see if there's a difference between groups, what are you looking, like, you're looking at that absolute value, but you're also looking at what? Because you're also, the error bars are missing.
Yeah, error.
Because any of the significant differences is like, it all depends on how much error there is. So, and you're saying here that there is a significant difference?
Yep.
And you measured that?
I did, but it's not on here.
Okay.
Yeah.
So you did what kind of analysis?
I honestly can't remember what it's called.
Okay. So when I looked quickly at your poster too, some of the things weren't clear what you guys have done, especially with results. So I don't know which values you compared to the other. And so then whenever you discuss and you make conclusions, I can't look at that and be like, okay, yeah, that makes sense. You checked that they correspond to each other. You checked that those values actually make a difference. I see a bar graph that, oh, this value is bigger than that, so I'm going to conclude based off of that, and only that. So did you look at each individual group too?
Yeah, yeah.
And did you see like a stepwise difference, or?
Across each individual group, the only real difference there was so each individual person, when the box size was bigger, had a higher result than when the box size was smaller, and the same with the distance across each individual participant.
Okay.
As well as a group.
And so when you're discussing this with the results, who did the discussion more? Which paper do you think it most likely corresponds with the results you found here?
Well, we sort of went with both of them. The graphs.
No, the findings you see in what we tested. What were the most similar results? Like
Yeah, the Xi.
the Xi?
Yeah.
Why?
Because there was not as much of a correlation between the speed and the accuracy.
And was their testing similar to this
So, yeah.
testing?
Yeah.
Their testing was about putting
Computers, so
yeah,
the
the
dots but on computers.
dots put on
Okay.
computers, and they also found that there was a very low correlation
Through
between-
complex 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 and simple measures.
And did they also see kind of these groupings that it's more the distance and the size that matter?
Yeah.
It's not just the speed and the accuracy together. So they said there was not a speed and accuracy trade-off, just
Yeah.
speed and
But
accuracy. There were more variables.
Yeah. So the
than
index of
just-
difficulty,
Okay.
so how difficult the task was, affected the speed and accuracy, but there wasn't necessarily speed didn't affect accuracy, and accuracy didn't
Okay, so
affect speed.
you're talking about the index of difficulty, because that was part of this, and
Yeah.
they were each rated, I think, 1 to 8 or
Yeah.
something like that. And you found that that made a difference, or not?
The index of difficulty, yeah.
Would it have been nice to also include that
Yeah.
here in the, because you guys obviously have read the papers, but, okay, so, Vicky, do you have some questions?
My questions are going to be around graphs, so you've already asked them really.
Yeah.
My only question would be, thinking about today's lecture, would this, and last week's lecture, what's going on here? Would you say it's more closed loop or open loop stuff? And I think that might be you, Susie, because you almost touched on stuff that would fall into that category.
I'd say it's more closed loop because it's not something that you really have to think about to be able to, like catching a ball, you have to think about where it's going to be.
So you mean it's open looped because it's
Yeah.
more automatic, subconscious?
Yes, sorry.
Yes. Yep. Okay.
Opposite way around. Yeah, so if it's open loop.
More open loop. Okay, thank you.
So if you would do this again, what would you do differently with your presentation? Or,
Probably a bit more elaborate and clear without graphs and information, just so that there isn't a gap between what we know and what we're trying to get across to the audience.
Relate it back to the previous research more.
yeah.
Yeah.
If that index of difficulty would have been especially if you said your findings really match that. Basically, you say here, oh, it doesn't really correspond, and you cite one paper. But if you also said it did match the difficulty, and that's in there, that would have been a very useful thing.
Yeah.
And to show maybe a table that shows the different results from the group, so other people can look at it and see all the information. So,
Yeah.
but, good. Oh, and you're missing your names on here, which is quite important. So, yeah, that one jumped right out. So,
It's not that.
which group number are you guys?
Two.
Okay, great. Thank you guys.
Cool, thank
Yeah.
you.
So who wants to be second?
Yes, handouts. I'll hand it out.
Yeah, good luck with that.
Nice.
Which group are you guys?
Good afternoon. We are Group 1, and today we're going to be talking about effectiveness of feedback to reaction time. It's me, Adil, that's Matt, and that's Dave. And I'm going to call Matt up first to speak about the introduction and aims of the experiment. Matt?
So the focus of our experiment was reaction time using the BATAC board. So first I'd like to ask the question, what is reaction time? And reaction time is the measurement of a person's ability to respond towards a stimulus. This is done by the nervous system recognizing the given stimulus, sending a message to the brain, which then travels to the person's limbs, The reaction time that we focused on was simple reaction time, and this was the recognition, and this is defined as a one response and one stimulus. So a person would respond to the stimulus given. So the average adult is able to react towards light stimuli in around 190 milliseconds and towards sound in 160 milliseconds. Reaction time can differ between individuals and can be influenced by factors such as age, gender, and their lifestyle. So why is it beneficial? Improving an individual's reaction time is beneficial as the individual is able to make faster decisions and movements. This gives an athlete or sports person the upper hand as a significant difference in reaction time can determine the outcome of a game or a rally. This can be done through measuring and observing the individual's reaction time and by using effective methods and testing. Observations towards the individual's reaction time can then determine what can be done to improve their reaction time. So our aim is using a backtrack board. A sample of individuals is tested for reaction time and response time. Half of the sample received feedback, whereas the remaining members did not receive feedback. Observations are made to identify whether there is an improvement or unimprovement in both groups.
Okay, so I'm just going to be talking about the methods of this experiment. There were a total of 12 individuals in this experiment, divided in two separate groups, Group A and Group B. Group A was given feedback in the form of time at the end of the experiment or every trial, and then the Group B wasn't giving any feedback. The Batic board had two LED displays on each side showing the score and the time recorded to 1/10 of a second. Individuals were split in test groups and were given first warm-up trial following 3 trials with 3 minutes rest period between those trials. The results were all recorded in the tables there. Since we didn't have a big number of trials, so we couldn't plot any graphs on it, so we just recorded the results, and Dave's going to come up and discuss the results of the experiment.
So participants were given the exact same set of instructions. No encouragement was given. There were 2 sets of groups involved. One received visual feedback and the other one didn't. And the participants were required to take a 3-minute rest between each trial. To complete the 3 trials within the time limit as well. These are the results for A and B. We did some research about what is the Batic board, where it came from, how much it costs. So I ended up ringing England because I couldn't find anything on the net. Rang a guy in Australia, Sports Sim, and he gave me a little bit of information, and with that information I rang the guy who runs the company. So the Batic board is a device used to test and train, I thought, simple reaction time, and then after a bit of study I actually looked into it, and it's probably closer to complex reaction time. In the definition, complex reaction time stated that it was a test between 2 stimulus or different stimulus, where this was actually looking at one stimulus among many possibilities. So I thought complex reaction time was the closest, so that's a little wrong. It does this by lighting up a random series of lights that are displayed in a large square. When a light glows, the participant presses the light as soon as possible. The number of presses are timed and recorded. There are a variety number of programs that can be used. It comes in 3 different types: Pro, which is this one, Light, and Micro. Short for Batic, the Batic board was developed by the owner of Quadronics, David Nelson. I actually talked to the guy on the phone. It first came on the market in 2007 and has been in constant development ever since. So it's actually been around, not in Australia for very long, but in Europe for quite a while. and he just keeps on making it better, refining it. Well, the Batak board was first developed for tennis players to improve the reaction time, and now is used to improve reaction response times for a variety of different sports. If you want to buy one, they only can be ordered from Quadronics in the UK. A guy called David from Sim Sports gave me an approximation of that one's worth 18,000, the light 11,000, and the micro $5,000. If you go to the UK and buy it yourself, £5,500 for that one, £3,850 for the light, and £2,850 for the micro. To hire the Batak board in Australia, it costs you $1,200 a day, plus shipping from Sports Sim. And they were the only people I found who actually hired as well. Okay, here's an example of the world record hire for using the Batak board. It's 173 hits in 1 minute. Hopefully all play. If we can go full screen.
You probably, I'm not logged in, you're not going to have internet.
Oh, okay. That's okay, man.
Yeah.
So
Okay,
we'll just move on.
Forget that bit. There he is. He doesn't move fast. Okay. For discussion, we were looking in non-feedback conditions resulted in an improvement towards the time of each trial, where feedback conditions show an improvement in the trial, which is pretty well exactly what we thought would be the opposite. We thought the feedback would help people get better, but the results show that they did not. Overall performance significantly. So yeah, the second trial was the one that received no feedback. They improved. We looked into the reason why the fact that the feedback would be people who didn't receive feedback would have a better score. I just found one paper who said that however is identified the relationship between feedback and results are difficult to assess, and in many cases feedback will improve performance, but in other cases it will decrease performance, and sometimes it will have no effect at all. I looked into the reasons why this was so in the paper, and I found it actually quite difficult to understand what was written there, but basically what I got from that was some of the basic assumptions on testing for positive feedback, or not positive feedback, but feedback versus no feedback. Some of the assumptions were flawed, and the whole paper was on why this was so, and looking into doing some tests that could more accurately assess it. And that's it.
Yep.
Oh, that's the conclusion of that.
Okay, nice, thank you. So how did you come to the conclusion that no feedback was better than feedback?
Looking at the results.
Can you go back to the slide so everyone can see that?
Yeah, just if you could open up the results, please.
And just for your information, this is really hard to read for us.
Oh.
Like that's.
And that's every results and the hand.
Yeah, but in general,
Oh,
yeah,
sorry.
okay, but, okay.
Maybe we should have resized it.
So in what part of the results tell you that no feedback is better than feedback?
So group A scored no feedback, group B scored more feedback. If you look at the mean time, it says in the discussion that in the group receiving feedback, which is group B, most individuals showed an improvement in their third trial when compared to their first or second trial.
But so you just did you count, like is this based off of an absolute time, or is this a relative, like how did you compare?
We just compared each time
Using the mean of
the trials.
Of each trial. So
Yeah.
you based, and then you did statistics on this? Or-
Statistics.
Yeah. How can you say that one group is better than the other group without testing it?
We're just talking about individuals, not groups.
You're talking about groups because you talked about the mean, and you're talking about
Yeah.
individuals. So they're different things. So
the mean from group A to group B, the group B, which was no feedback, had more improvement. So that's what we did. Yeah.
No feedback did have no improvement, but the conclusion states that, however, it is identified that the relationship between feedback and results are difficult to assess.
okay, and then one comment I heard somebody say is that there's not enough participants, you can't make
No,
graphs.
not enough trials.
Yeah, but you can still analyze this.
Yeah.
Yes, so looking at those, we did come up to the conclusion that the relationship between feedback and results is difficult to assess.
I have
And
no.
also, I guess, the small
And-
sample size.
Yeah, a
Yeah.
more bigger sample size will give us a better correlation.
But as far as what you've done, I haven't seen anything that you've done. I've seen that this is the table that was given to you that you've pasted in there, and then you said no feedback is better than feedback, and haven't told me how you got to that conclusion.
Can you answer that?
And
Because I would have been expecting some statistics.
Yeah.
Yeah.
Absolutely.
So that you could say it was significant or not, and then you could make a more solid.
and also just showing what you compare. So like one person says, oh, I compared relative to the individual, and then the other one says, oh, we're looking at the means. Those are two valid comparisons, but different ones. And you didn't state that you did either of them. And instead in the methods, or the methods you just talked about, okay, here's the actual task, you didn't talk about how you looked at it. And in the results, you put the slide up for 2 seconds and talked about the pricing of the BOTEC board. We're looking more at the discussion of, hey, did feedback make a difference? If it did it during the trials? Did it while people practice? So asking questions about the test setup, or what was wrong with the test setup. Maybe somebody didn't get enough rest, or this was more of a task to make you look into the data and ask questions about reaction time and how it relates to motor control. I haven't seen any discussion related back to those questions. Do you have any questions, Vicky? Or anyone else have questions?
I have questions which are the results again, because me looking at it on here, to me it looks like the no feedback is actually getting slower, whereas the one with feedback is getting quicker, which is opposite of what they're saying. That's me looking at the results on this poster. So, I don't know, yeah. How do you get your results and I'm seeing something different?
I think consistently it shows an improvement on group B from the first to the second. All the way through.
I think, so you're saying
45, 44, 46, 42.
the non-feedback are improving from the first one to the last one?
Yeah.
Yeah, that's right. Yeah.
Yeah. So I consider that there's an improvement that goes from the first trial being the mean being 54 to the last being 48. But I think overall is the one with the feedback still lower across the board?
Yes.
In general, also, if you have individual, reaction time will vary by the individual. If you have that, you also have to take that into consideration when you're just looking at group averages. So you would have to go into the results more. And there are enough samples and enough trials to be able to go in a bit more and dig into this and show some graphs and talk about whether the average changed or the error, or if it was more participant-based changes. So, okay. Anyone else have any questions?
I mean, it's obvious to me that you've looked at means for the individual across all trials, plus you've looked at the means for each individual trial, which is exactly what Beck's saying. You could have done stats on all of that. You could have really, you could have really got into the depth of it and given us some meat to discuss. So I
we needed to take it like a step or two further with those numbers.
Quite a few. And then also, if you go in and you're saying, hey, there's no difference between groups, put them all in one group and then just talk about reaction time in general. So you can take data and look at it in more detail. And if you aren't seeing typical trends out there, talk about what is typically seen and why you might not have seen it. So I'm just missing the discussion and the results here, which are usually the main meat of an assignment like this. Thank you, guys. Thank you.
I'll signal to you. Ready?
Yeah, thank you.
Hi everyone, I'm Gabe and this is my group.
Hi, I'm Ambrose.
And today we'll talk to you about feedback. For our group's experiment, we asked each other what exactly is feedback, and we hear the term all the time in sport and especially in motor learning. But do we truly know what it is and why it's so important? Sarah Ways, a writer for the Snap Survey blog, explained 2 reasons why feedback is important. Sarah described feedback as a tool for continued learning. Feedback is important across organizations in order to remain aligned to goals, create strategies, develop improvements, and much more. She also pointed out that feedback can improve performance. This became relevant to our group's study to explore feedback and its relationship with better or improved performance. Feedback is defined as information about performance or errors that the learner can use for making future corrections. There are variations in how feedback can be delivered, in such as frequency, timing, and type. As per our study, we manipulated the frequency and timing with immediate versus delayed feedback, and as per type, we used augmented feedback. What augmented feedback is just consists of information from the measured performance outcome that is fed back to the learner via some artificial means, so a computer or feedback from a coach. Feedback can be delivered in many ways, from the athletes themselves and from outside sources, or intrinsic and extrinsic. When an athlete performs a movement, intrinsic feedback will always be there, and it's harder to manipulate as it is subjective, whereas extrinsic feedback, due to its external nature, it's easier to manipulate and control and can potentially affect intrinsic feedback. 2 ways in particular is the timing of delivery, immediate or delayed. So in addition, external feedback has greater effect on performance outcomes. Just a definition with delayed versus immediate. Delayed feedback occurs when there is a period of time between skill, execution, and feedback. Delayed feedback has shown to be more effective for simple skill, performance, and learning. Immediate feedback occurs right after the execution of the skill, given from external source, i.e. verbal. So delayed feedback's better for simple tasks, therefore we suspect that there would be more effective than immediate. When immediate, there is no time to retain information. This table is just comparing the 3 conditions and what have changed. The intrinsic feedback for our purpose is constant throughout all 3 conditions, and we have manipulated the extrinsic feedback and timing. So our hypothesis is that we believe that delayed feedback group will perform better and all the other groups will have a better score by the 3rd trial.
So the tasks are the pre-test or the practice test that we do is to basically, using that target you see over there, throw the ball 10 times to try and reach the yellow centre with no feedback and no blindfold. And then we go into the official trials, which you get 3 of in each set of feedback, where you do exactly the same but you get different types of feedback and you have to wear the blindfold. And these are just the scores that we use when giving the feedback. Right, now the equipment we use for this is, we could have used beanbags or tennis balls, however in this one we used the beanbag balls with 10 throws. Then we have that archery target, which again we used for the multiple coloured rings because depending on where they've thrown it, that's the type of feedback they get. And then we also have the tape, which is for pinning up the target, and also from 4 metres back from the target we draw a line with the tape just so the thrower is the correct distance away. And then lastly the blindfold, which we use throughout all of the throwing. So thrower A is best described as non-specific and has immediate feedback. So this is the only feedback that can be given. The helper standing by the target will tell thrower A which colour they have hit after each ball has been thrown. The thrower first throws the ball 10 times as a trial run, and then once that is recorded with no feedback and no blindfold, we go on to the official ones, which again are 10 throws each. These ones are, however, with a feedback and with a blindfold. And again, the helper will call out the colour that has been hit, the scorer will tell the recorder, and the recorder will write it down on a piece of paper. So we then go on to thrower B, which is specific and immediate feedback. So this one, the feedback that can be given only is immediate. The helper standing by the target will tell the thrower B which colour they have hit after each ball has been thrown, as well as the position. So for example, blue 10 o'clock. Then the thrower throws the ball 10 times as a trial run, moves into the official ones, and then the helper will call out the colour and position that has been hit, and then the recorder will only record the colour. So the position is purely for the thrower's use. And then we move into thrower C. So the feedback is delayed feedback. So only can be given delayed. So the helper standing by the target will tell them which colour they have hit as well as the position for the previous throw. So like thrower B, blue 10 o'clock. Now the trial runs commence with no feedback and no blindfold. We then go into the official ones with the feedback and the blindfold. So first throw, the helper will not call out the colour or position that has been thrown, only throws following that. So the thrower will complete their first throw and not receive any feedback. After the completion of the second throw, the helper at the target will reveal the colour and position of the first throw. And then so on, the scorer will tell the recorder the points worth of the colour, recorder will record, and again the positions are not recorded for this thrower either, it's purely for the thrower's use.
So if you can't understand me, with the results that we've got, we decided to put everything into one and kind of just get an overall average of what it actually was. So this one here is figure 1 on your sheets. It is the test one where you did it with no blindfold. The test conditions is the one where you was blindfolded. So we just summed up all of the ones that were done and averaged them out into groups A, B and C. We noticed that there was a drop in each one of them from your baseline, of your practice one, sorry. So there was a 50% drop in group A, a 42% drop in group B, and a 33% drop in group C.
Since there was a, can we go back? Since there was a less drop in group C, which was the delayed and specific feedback, that shows that it's the best. So let's go next one. So to understand why group C would be the most ideal feedback, we have to talk about specific versus non-specific and immediate versus delayed. So there's level of precision of feedback that you can give So one of the examples that I use is because I used to do karate, and we call this the back dance. So when most beginners do it, they don't put as much weight on their back foot, and they're usually evenly distributed. So a not too specific feedback would be put more weight on your back foot, but how much weight? So more specific feedback would be put 80% of your body weight onto your back foot and the rest on your forefoot. So and when immediate versus delay, Paul King found that individuals tend to ignore and do not retain immediate feedback, so they don't process it. And we also found that participants in the third trial did the worst compared to the first trial, which you should do the best on the third trial because you've been practicing already. We concluded it was because since it was late in the afternoon, most individuals wanted to leave, and if they weren't getting the right scores, they might get frustrated and lose motivation.
With the conclusion, just going back on what Gabe said, and the hypothesis is that Group C was the better one. The results tallied out to say that Group B was the actual one that, with the immediate feedback and specific, was probably the best one to actually have. Yeah. Any questions?
So are you saying Group B or C is?
Oh, Group C. Yeah, I think Tim just said.
Group C, but
Yeah, I think that's
Group
Tim.
B is, yeah.
So
But the scores would potentially suggest otherwise?
no, the score suggests Group B, but if you look at the baseline, Group B's baseline score was higher. So, and you can see that there was more decrease in performance in Group B compared to Group C. So therefore, Group C would be more superior with the delayed
So
and specific feedback.
Did you, how did you test this? Again, going into more of the statistics part of it, how did you assess that B was better than C or C was better? How did you?
Well, in the
check?
perfect scenario, we would get everyone in the same to do A, B, and C, but since we don't have the time, this is what we, so you can just look at the baseline and
Yeah, you can do that, definitely.
Yeah.
But did you do that? Did you then subtract out their baseline scores?
Oh,
and
yes,
then
we did, and we found out the percentage difference.
And then did you test that for like a t-test or an ANOVA or anything to say, okay, is this significantly different than the other?
No, unfortunately not.
Okay, but so the subtracting out is how you got the percentages, and
Yes.
so that's why you're the drop off wasn't as big, so we think that this is the best.
Yes, and research we did showed as well. Yeah.
That seems fairly counterintuitive to me, though. Just whenever I was doing it, I didn't like getting delayed feedback. So, why do you think it is again? Can you try to? I know you said.
Oh, yeah. So the research shows that immediate feedback, people usually don't take it in as much. They just ignore it, just hear it, and then they don't process it through. While the delayed feedback, so when you throw it, like, oh, what's my score? And then you think about it, oh, did I do wrong? And then you're given the feedback that's more ingrained into them, so they'll do better on the next throw.
But would that be more like if somebody's performing in, let's say, athletics or something, after the run, there's a little time, and then later you talk to them about their form and you analyze it. This is kind of a different setup, wouldn't it be? Because somebody throws it once, you wait just until after the next trial, and then you give it. So the delayed feedback is still during the action. So was there ever a difference in the literature about that kind of, whether it's during the performance or after?
Most of what I read was after, but I still apply it. Since the results showed, I thought there must be a correlation.
Okay, because I think that kind of delayed feedback is whether or not it's during the action or after, not during versus during, but different conditions. What's another thing you might think about that you would change about this design to just see if feedback even makes a difference?
The task, because
Yeah.
it was a simple task, so we'd expect everyone basically to get an all right score. But it didn't show it in the results. But I've seen everyone's third trial, they scored poorly, which it should be higher because they're getting that many attempts to correct their movement and that, but didn't.
You guys thought that might be due to motivation? Do you have any other ideas on why that might be?
We said timing, timing of day.
Well, I was relating back to my results because I scored poorly, and I was saying that my frustration was kicking in because I could hear the feedback of the score, like saying 0, 0, 0, was getting me frustrated, and I was just throwing off.
But wasn't it also the third trial was further from the trial where you weren't blindfolded? So you were getting further and further away from when the time you could see how well you did and where you were throwing. Too.
Yeah, can, the patterns, I haven't read the research, right? So I'm just thinking of this logically here, so you can help me out here. If you are getting delayed feedback, are you actually reacting? Are you actually using that feedback? Okay, so in the third scenario, right, you've got the feedback, what Hazel said was kind of from 2 goes ago, right?
Yeah.
So the question is, when you were actually doing it, did you feel like you actually took that on board and altered what you were doing? Or did it become irrelevant?
I think there was a reference in the discussion about how the attention increases over that delay period, and which allows them to think about more. With the immediate, it's just that quick. But then again, because it's a simple task, it shouldn't be. They really shouldn't think about it as much because of the intrinsic stuff, because you're internally giving yourself feedback.
Yeah. Since we're blindfolded as well, it's not a thing that we usually do. So, because for my research, I said immediate feedback is usually used on actions that you would do automatically. So maybe if you're like a sprinter, like take off, that's automatic. Delayed feedback is usually applied on situations where you have to think about it quite a lot. So since you're blindfolded, and you don't get blindfolded, so you have to think. So
yeah. So if
so I think that's.
Wouldn't you need immediate feedback more?
Yeah.
So would your immediate feedback throw to throw?
Sorry?
So at the beginning, before or after each throw, was that the immediate feedback?
Yes, so after you throw, you get the feedback.
And was your feedback like you hit red above the middle, below the middle?
Yeah, it was a clock, yeah.
Red, 12 o'clock.
That was in.
So if you're blindfolded, I think me personally, immediate feedback would be much more beneficial, because then I would somehow be able to alter how I'm throwing the beanbag or the ball, to perhaps try and lower the throw or make the throw higher, so I can try and get the middle.
And that's kind of what I'm trying to get at, is that if you, so when I've done implicit learning with athletes before, so for example with my golfers, right, I'll get them to close their eyes and hit golf balls, but they're not allowed to see where the ball lands, and that pisses them off hugely, right? It annoys them. But then they're getting very limited feedback. They get a bit of feedback through how it feels off the club face, but they haven't seen what the outcome is. So that allows them to focus more on the process and less on that, okay, I've got that outcome, I need to now alter how I'm going to throw it, which is what Yanni's talking about. Whereas you get the immediate feedback, I'm going to alter that because I was a little bit, I was at 2 o'clock well off in whites department. Oh, okay, I need to bring that in a bit more and I'm going to throw it more like this, even if I've got a blindfold on. That's what I would do. I'd be altering. Would you guys agree with that?
I agree with that, but what the research I showed is people usually disregard it. So that's why I thought that the delay would be better, because I saw some group just, okay, yeah. Yep, let's go. David.
Reflect that the delay feedback was actually more successful than immediate feedback.
Yes, so this is what I'm trying to get at.
So it's
right?
counterintuitive.
Yeah. So it's counterintuitive, which is what Beck's saying. And so we're trying to understand why, and although the research may not back that up, there's still room for you to put your opinion in, or to look further through that logical process. If you're getting delayed feedback, I'm not going to alter my process. Okay, I'm going to keep doing what I've been doing, which I think is going to work. I'm going to have more trust. I'm more likely to be using the GMP or the main neural pathways that I always use and not try and mix that up. And that's probably why you're going to get better performance from my understanding of this area. Does that make sense? Yeah.
It shows that in the blindfold in Group B, which was the immediate specific, where you were saying that you'd work better in the Group B category, where it didn't support our hypothesis with delayed feedback being better than immediate.
You guys made a comment earlier, and I'm quite curious about it. Did you set your hypothesis before you looked at the results, or did you see the results and then make your hypothesis?
Yeah, we did say at the start of it, yeah.
Because it sounded like you said, oh, I saw the results and it wasn't what I expected, and then we...
Yeah, we did say specific was first. So we were kind of influenced by results in a way.
Yeah.
But part of it we did say at the start.
Okay. Well, I mean, yeah, you didn't set up the experiment either, so
Yeah,
it's just a curious
there's,
question.
yeah,
So
no point,
there's all
yeah.
of it.
But when we were discussing, we did say specific would be. So.
Yeah. Thank you, guys.
Thank you.
All right, so if you guys haven't uploaded these online, can you do that right away? And then the other part is get those individual assessments